Hello guys. In this video we are looking on the methods of how to solve ordinary differential equations using the exact differential. So for example, we are saying solve 1 minus this and this. Now I've introduced this concept, so I'm saying if I'm given, so the first step we are checking for, we are saying check for exactness. So check exactness. So how will we check exactness? This is using Alexis Cloud theorem. Now we are saying if I take m of x, y, dx, added that to n of x, y, dy equals 0 is exact only if the derivative of m with respect to y is the same as the derivative of n with respect to x. Now, having this knowledge, we are saying we should get the derivative of m and n. Now we are saying from this point, so I'll indicate something. So from this point, I'm saying this is my m. Always take m to be on the left side. This is my n. Now, if I take m, so I'm saying m of x, y equal 1 minus 2xy, and I take n of x, y equal 4y cubed minus x squared. Now from this point, let's find our delta m upon delta y. Now I'm taking the derivative of m with respect to y. So if I take the derivative of m with respect to I, so this is our m, I'm saying this just I'll treat, if I take with respect to y, I'll treat everything to be a constant. So I'm saying if this is my constant, so it will go to 0. If I take the derivative, I should get minus 2x, so that's a constant. Then I'll differentiate y, I should get 1. So this is simply negative 2x. Now if I take the derivative of n with respect to x, I'm saying all the y's in that equation should be my constant. So for this case, it's a constant. So if I differentiate this constant, should get a 0. So this is just negative 2x. Okay. So if I differentiate this, I should take 2 to in front and then minus 1 to the power. Okay. Now, as you can see, we already checked for exactness. We're saying delta of m with respect to y is the same as delta of n with respect to x. Because it's negative 2x equal negative 2x. So this statement is true. So once we have checked for exactness, we are saying how will we solve this? So let's do a small cross multiplication at this point. Okay, now we are saying delta m, multiply that with delta x, and then don't include the equal sign, just separate using a comma. I'm saying delta n with respect to integrating that with delta y. Now first, to solve this differential equation, we are saying integrate both separately. So I'm saying the integral of delta m dx. Okay, now so what's this? So I'm saying this is the integral of 1 minus 2xy, okay, dx. So this means I'm integrating this function, okay, with respect to x alone. So I'll treat the y, all the y term equal 0. Now from this point, we have a partial x raised to 0, okay, at this point. Now if I integrate this, I should get x, okay, I should get x minus, if I take 2y as a constant, because we are not respecting to that, then integrating x, I should get x squared divided by 2. If I simplify this, I should get x minus xy, okay, should be x squared y. Okay, now let's perform the integral of delta n dy. Okay, so this is the integral of 4y cubed minus x squared dx. Okay, now we are integrating this with respect to x alone. Now where there is a should be dy, sorry, should be dy. Okay, so should be dy. So I'm integrating this with respect to y. So every x term should be a constant. Now, if I integrate this, I should get 4 multiplied by y to the fourth, divided that by the power. So I'm saying minus, we have a partial y here. So we have a y raised to 0 at this point, okay? So if I integrate that, I should get treating x as my constant, so I should get x squared multiplied by, if I integrate this, I should get y. Now simplifying that, so I should get y to the fourth minus x squared y. Now, so let's simplify our answer. So remember in my previous video we said if we're able to say something it's exact, okay? If you are able to get the derivative of f of x, f of xy, okay, in this manner of f m of xy dx plus n of xy dy equals 0. If we're able to do this, we are saying we have a potential function. We have a potential function. So we have a potential function, say f of x y equal a constant c. So how will we manage this? So we are saying this potential function is our original function. So for example, we had a function using implicit differentiation, we were able to calculate the derivative of this function, okay? So if we differentiate that, we usually get this. So this is our first derivative that we have used implicit differentiation. So for us to get back to this function, okay, for us to get back to this function, we must use exact differential. That's the core concept to this video. Now we are saying from implicit differentiation, we are getting back for us to get our original function. So this is the process we are obtaining. So our potential function is our original function. So I'll just maybe name this original function, okay, that we had earlier on differentiated. Now, so let's continue with our work. So we're saying, how will we get our potential function? So let's write whatever we have integrated. We are saying we have integrated and got y to the fourth minus x squared y, and also we have got another, say, x squared. We're saying x minus x squared y. Now, for us to get our potential function, we are saying write every term once. Okay, write every term once. So I'm saying x minus x squared y, then I'll add that to y to the fourth. Now if you see x squared y has repeated itself, so we shouldn't write that, and then I'll just put that equal to c. So I'll say this is my general function. Okay, so if you have a potential if you have our initial condition that satisfies this equation, we are saying if you put the initial condition to this, we will get our original function. So please like, share, and subscribe. Let's counter more problems. Keep learning. Thank you.